All right, let's not discuss that anymore because now we got video going.
All
right, so you're still working on the quiz. You need to bring it up, get it wrapped up, bring it on up. We are now going to hopefully make a good dent on our remaining notes. We don't have that much more to go. And then remember, we are just going to have a quest over this, not a full-fledged test. So, and we have homework that's posted. Homework's in there. All right, so 6.2, we're on the back of page 50, and we have one problem to go. On the back of page 50, we have to find the angle between this vector and this vector. So we're going to find the angle between those two vectors. Now, we did this yesterday, a couple of different steps. Does anybody remember the first thing we do when we want to find the angle between two vectors? Well, we're going to need the magnitudes, but I would suggest that first, not that usually it's going to make a difference, that if in fact they're perpendicular, it will make a difference. So let's find the dot product first. We're going to need those magnitudes. We're going to find those magnitudes, but let's do the dot product first. Someone asked me yesterday, Mrs. Ford, which one's U and which one's V? Doesn't make a difference. I'll just say I'm going to dot -2,4 with -5, -2. Who remembers how to find a dot product?
X times X, Y times Y.
Exactly, and add them up.
Yeah.
So X times X is 10. Y times Y is -8. So the dot product is 2. Now the next thing, okay, let's just pause a moment. If by chance that is 0, that means the vectors are orthogonal. We talked about that in our last example yesterday. If the dot product is 0, it means the vectors are orthogonal, perpendicular. These are not because the dot product was 2. So now I need the next step. So as Shelley said, the next step is to find the magnitude of each vector. To find the magnitude, we square, add them up, and square root. So the magnitude of V is 4 plus 16, root 20. Now, that is not the answer, so don't simplify it. Just leave it be. Leave it root 20. If I were going to use that, write that in the answer blank. I'd want to reduce it, but I'm not going to. Magnitude of U is 25 plus 4, root 29. Anybody remember what I do with those two magnitudes? Multiply them together, and it's going to be just one radical. It's going to be the square root of 580, 20 times 29. Now I'm looking for the angle. I know the cosine of the angle. This is the angle right here. The cosine of the angle is the dot product divided by those two magnitudes. Always cosine when you're doing the angle between two vectors. You're always using cosine. And how do I get a number from my calculator then? What buttons do I press? Second cosine. Right, so I gave away my calculator. Somebody type in second cosine. 2 over the square root of 580. So second cosine 2 over the square root of 580.
1.999. I got 85.24.
Yeah. Are you in radians or degrees? What is it?
85.24.
85.24. So theta is 85.24 degrees. Second cosine, you're going to press second cosine 2 over the square root of 580. and it should say 85.24 degrees. Right? All right, now, the next section says, are these two vectors orthogonal, parallel, or neither? Now, orthogonal means perpendicular. So, are we perpendicular, parallel, or neither? One way to do this that's real quick and is total review of what you've been doing since like 6th grade excuse me, is to look at their slopes. So one way of doing it, which is perfectly fine, is to simply examine their slopes. So, if we look at the first vector, which is 2, 1, and negative 2, 4, what is the slope of this vector? Now we always have to remember that slope is y over x. When you calculate slope, don't you do y minus y over x minus x. Slope is rise over run, vertical over horizontal. So the slope of this vector is 1/2. This vector goes over 2 and up 1. Its slope is 1/2. What's the slope of this one?
Wait, no.
-2.
4 over -2, so -2 over 1? What's the relationship between these two slopes?
Reciprocals.
They're opposite reciprocals.
They're orthogonal.
So these are orthogonal. These two vectors are orthogonal. Now, if you want to, you could do a dot product. If you do x times x and y times y, what happens? You get 0. And we already know that if you do a dot product and get 0, the vectors are orthogonal. So that's another way you could have done this. Personally, I like the slope way because it can also show me parallel. The dot product doesn't show me parallel. All right, so let's look at B. We've got 2, 1 and 6, 3. All right, what's the slope of this one? 1/2. What's the slope of this one? 3, 6. 1/2. So what's the relationship between those two vectors?
Parallel.
Parallel. Boys and girls, if things have the same slope, they're parallel, right? If they have opposite reciprocals, they are orthogonal. But if they're the same, they're parallel. All right, how about 2, 1 and -5, 7?
Neither.
This one is 1/2, this one is 7 over -5. That would be a neither. There is no relationship between those two. How about D?
Neither.
Kalman's shaking his head. That's a neither because the slope is -1/3 and 1. No relationship. Neither. How about E?
Yeah, parallel.
They are parallel. Look at the two slopes, you guys. Aren't they the same? That means the vectors are parallel. How about the last one? That's -1/3 and 3 over 1. So F is orthogonal. Everybody okay? So if you need to answer the question, are they parallel, perpendicular, or neither? You are going to just think about slope. That's your easiest bet. Just think about slope. And slope is always y over x. Always y over x. Okay, you said this is the lunch period?
I think it's
I don't think quite yet.
One more problem.
What time you leave?
All right. All right, so now we're going to look at, we're going to do one problem from this first section. So here we go. Actually, you've already done this. You did this back in chapter 1. I don't know if you remember it or not.
No.
Probably not. But you actually did do this. Is there anybody who can just make my day by remembering how to eliminate the parameter?
Well, T equals
What? I heard someone.
T equals X minus 1. T equals X minus 1.
So we're going to come right up here. I'm hearing some people that kind of know what to do. Somebody said, trade this out, substitute completely. This says T equals X minus 1. So I can take that right there and substitute it in here. And then my equation does not have a t in it anymore. T is the parameter. It is that third variable. We can get rid of it by getting it by itself and then plugging it into the other equation. So now I'm going to do a little bit of basic arithmetic. Does that look okay? Now, the directions say eliminate the parameter, done. Identify the curve. So in other words, I didn't know what this looked like, but I should know what this looks like. What is that? Y equals mx plus b, which means it's a slope-intercept form of a line. So when it says identify the curve, you say this is a line. Now you might have one, I know I'm building up your excitement, so once you can think about this, you might have one that turns out to be a parabola. What will happen if it's a parabola? You'll have a squared in there, right? There'll be a squared in it. If there's no squared, it's just a line. Well, we'll do the rest of these when we come back. Let's see what time I need you back. I need you back at 51. 51. What do you mean you put the wrong number next to it?
Instead of